Good morning, ladies and gentlemen. This is Mr. Rowe looking in geometry part A. This is lesson 17, and we're going to talk about parallelograms. Again, this is some content that's already in the lesson. I'm just going to try to explain it using some different words. So if you're not understanding it when you're reading it, then maybe you'll hear me say some things that'll make it click for you. So let's take a look at the characteristics of a parallelogram. Now, these are listed as theorems in the lesson. I've got the theorem listed with the characteristic. So first one is that opposite sides are congruent. So that is theorem 17.1. So if we have a parallelogram, opposite sides, remember, are these sides across from each other. So these sides are congruent. Now remember that a definition of a parallelogram says that these are parallel. So that's going to be assumed here since we have a parallelogram. So those two sides are congruent to each other. Those pairs of sides. So those are congruent. Consecutive interior angles are supplementary. So now consecutive interior angles, so like A and B would be consecutive interior angles, or consecutive angles. So they are supplementary to each other. And so A and B would also be consecutive interior angles. Because remember, these are parallel to each other, so there are some characteristics of parallel lines that also apply to the parallelogram. And that is theorem 17-2. You look in the lesson content. So the next thing, opposite angles are congruent. So here, opposite angles, they're across the figure from each other. So A and C, for example, this is 17.3. Those are congruent to each other, and B would be congruent to D. So those are some characteristics that are in common to every parallelogram. One more is that the diagonals bisect each other. This is theorem 17.4. So here are, let me get rid of this stuff. So here are the diagonals. Now don't get confused by this property. This property does not say that these are congruent. So AC is in no way, unless it's a special parallelogram, congruent to DB. That's not what it's saying. It's saying that those sides are congruent, those sections are congruent to each other. So AE, for example, so from here to here would be the same as from C to E. So those distances are the same, so they bisect each other. And BE right here would be the same as DE. So that is the characteristics of a parallelogram. So now let's apply these properties to some problems that you're going to see in the lesson. So for example here, we want to figure out, this is a parallelogram. We're going to assume that the pictures in the next 4 slides are parallelograms. How are we going to apply a property to figure out what X is here? So now the first property we looked at said that the opposite sides are congruent. So to figure this one out, we're just going to set up an equation with one side equaling the other side. So 9x plus 5 would equal 41. And then we're going to solve the equation. So we'll subtract 5 from each side. That'll give us 9x equals 36. And then finally, we'll divide by 9 and get that x equals 4. So that's how we're going to apply that property. So let's take a look at the next property. So here is the consecutive angles. So consecutive angle theorem. So right here, these two angles together have to add up to equal 180 degrees. So we're going to set up this equation. We're going to add the two equations or the two expressions together and let it equal 180 degrees. So again, we're going to solve the equation, combine like terms. We're going to combine our 4x and 3x to get 7x. And we're going to subtract 5 from each side to get 75. And finally, we'll get that x is 25. Now from here, you could also be asked, what is the measure of each angle? If that is what you're asked, then you would just simply replace x with 25. So 3 times 25 here would be 75. So let's look at the next property. So the next property was that the opposite angles were congruent. So the angles across the figure from each other are congruent. So here in this example, 4x plus 5 would have to equal 75. So we'll set up an equation, letting them equal each other, and we'll solve the equation. So the first step here is to subtract 5 from each side. So that'll give us 4x equals 70, and then we're going to divide by 4. And when we divide by 4, we'll get x equals 17.5. So that's the first three properties. And then the last property, well, we've got diagonals bisecting each other. So here we have both of our diagonals. That's just to show that they do bisect each other. So what am I going to do to figure out y here? Well, again, I'm going to let this equal that. So I'm going to set up that equation. So this is an equation with variables on both sides. The first thing I'm going to do is I'm going to subtract 5y from each side. So that's going to give me 3 equals 4y minus 11. The next thing to do is to get rid of this 11 right here. So we're going to add 11 to each side. That's going to give me 14 equals 4y. And then finally, I'm going to divide by 4. And that's going to give me that y is 3.5. So that's how we apply the 4 properties to problem solving. Now we can also apply these properties to a proof. So here is a proof. You'll have a similar proof in your assignment. So let's take a look at what we have here. So here is our picture. We've got 2 parallelograms, and that's going to be our given. We've got this big parallelogram, ABCD. Then we have this smaller parallelogram, PBRQ. Now the important part here is that BR and BC, that's the same line. So BR and C are collinear. So that's going to be important to know. So our given is that we have parallelogram ABCD and parallelogram PBQ or PBRQ. We want to prove that AD, so this segment right here, this side of the parallelogram, is parallel to this side of this parallelogram. So that's, again, I like to think out what I'm going to do before I actually write the statements and reasons. So what I know here is that PR right here, because it's a parallelogram right here, will be parallel to PQ. Well, since this is collinear right here, well, this will also be parallel to this. And then we had a theorem in an earlier lesson that said the same line, if 2 lines are parallel to the same line, then those lines are parallel to each other. So that's how we're going to prove this. So let's take a look at how it looks. So we're going to set up our statements and our reasons. Our first statement is usually our given. It's always our given. So here we're given that ABCD and PBRQ are parallelograms. That's our given. And then because of the given, we know that BR right here is parallel to PQ. So that is the definition of a parallelogram. And while BC would be the actual side of this parallelogram, the big parallelogram, I can actually use BR because these 3 points are collinear. So I can say that BR is parallel to AD. And again, that's the definition of a parallelogram. And now since both of these lines, PQ and AD, are parallel to the same line, and those 2 lines are going to be parallel to each other because of that theorem. If 2 lines are parallel to the same line, then they are parallel to each other. So you'll have a similar proof in your assignment. I hope this helps you write that proof because it will be a very short, similar proof. So if you hope this helps you with this first part of the content in the lesson. If you still struggle with this part of the content, please let us know in a teacher message or make an appointment for a help session.